Alright, so this video is going to be all about the matrix itself and row operations. The first thing we need to talk about is the augmented matrix notation. So how I did this is I took my set of linear equations and I got rid of all of these variables. So here are my x's and my y's, and I'm just going to put them on top of a column. So here I have x and here I have y. Now underneath the x, so in this column, I put all of my constants. So first row is first equation. I take my first x, which is a 2, and I just bring that down here. My second row, which is my second equation, I have a 6, so I put the 6 down here. I do the same thing with my y's. Here I have 3y in the first equation, so I put 3 in the first row. Here I have 2 in the second equation, 2 in the second row. Now I'm going to draw a long vertical line like this, and this is going to separate my variables on this side from my answers on this side. It's kind of like an equal sign in a matrix. Now, first row, first equation, that's here, 24, I'm just going to write it here. And now 17, second equation, second row, write it down there. The difference between an augmented matrix notation and just a matrix notation is this vertical line is actually really important. So if you see it, it means everything on the right is the answers. If you don't see it, you're just dealing with a regular matrix just with variables. Alright? Now I have a set of linear equations here. And what I really want you to try to do is just try to write it out in augmented matrix notation. I have a 0z here, and when you're writing it out into a matrix, you just write 0. If it's a negative number like here, you just write -2. Now, once you have your matrices, you can only do a few things to them. The first thing you can do is you can do row addition. Now, when you have your matrices written out like this, see, this is just a regular matrix. It's not augmented because there's no vertical line separating my variables from my answers. You can only do a few things to the rows themselves. So one row is one horizontal line. The first thing I can do is row addition. I've written out here R2, capital R2, is equal to lowercase r1 plus lowercase r2. What this means is that my new row 2, that's my capital R, is equal to my old row 1 plus my old row 2. Now I didn't say anything at all about my new row 1, so I'm just going to write it out the same as it is before. I have 3 and I have 2. For my new row 2, I need to add the old row 1 to the old row 2. So if I come back here, I start with the first number. I have 4 and I have 3. I have row 1 and row 2, and now I'm going to add them together. So 4 plus 3 is 7, and I'm going to write it here in my new row 2. Same thing for the second number. I have 3 plus 2, so I have 2 plus 3, which is 5. I can also do row subtracting, which is the same thing, except for you subtract numbers from each other. Here I have capital R1. That means new row 1. I don't have a capital R2, and that just means that my old row 2 is the same as my new row 2. I just wrote it out. 0, -1, same thing here. 0, -1. But my new row 1 is going to be my old row 1 minus my old row 2. Let's have a look. First number, I have 6, which is row 1, minus row 2, minus 0. So that answer, 6. Second number, I have 8, minus -1, so that's 8 plus 1, and that is a 9. Another thing I can do is I can multiply an entire row by a scalar. Scalar is just a normal number. It's not a vector, nothing special with it. What I'm asking you to do here is to find my new row 1 and that is going to be equal to 2 times my old row 1. Start with the first number. I have 3. That's my old row 1, so 3 times 2 is equal to 6. Old row 1 is 1. 1 times 2 is equal to 2. I didn't say anything about my new row 2, so I just take my old numbers and I write them again. Now the last thing you can do is you can swap rows. So I can take this entire row and I can just move it around. But I have to make sure to take the entire row, not just one of the numbers. Here, I am asking you to take row 1 and swap it with row 3. I took row 1, so 2, 7, 0, and I swapped it with row 3, which is 1, 0, 6. So here you see 1, 0, 6 is now in the place of row 1, and 2, 7, 0 is in the place of row 3. I did not touch my row 2 because I didn't say anything about it. Now all of these row operations will come in handy when we start with Gaussian elimination in the next video.